So here I'll talk about linear combinations, and I'll begin with doing a little bit of a graphical description of vectors. So here we have a vector 8, -1. Well, another way to write this is 8, -1. And here you can see that this looks a lot like an ordered pair. In fact, it can be described that way. When we have a vector, we can graph this as a point, and we typically draw a line from that point in the origin, and that is how we graphically represent a vector. Representing vectors like this means every two-dimensional coordinate system corresponds to a vector, and we call this R2. So this R stands for real numbers, and then the 2 represents how many entries are in the vector. So these are all vectors with 2 entries whose entries are real numbers. If we want to do 3 entries in a vector, this is R3. And we can keep going. In general, however many entries in the vector is Rn. So what does this actually mean when we're dealing with things like scalar multiplication and addition? Well, multiplying a vector by a scalar changes the length. So if I have this vector here, and I multiply it by, let's say, 2, I'm basically just going to double its length. So we'll say this is x, and this is 2x. Multiplying by a negative will not change the length, but it will change it to flip around to the opposite direction. So everything that is multiplied by a scalar will still lie along this line. For adding vectors, we have the parallelogram rule. So that says if we have 2 vectors drawn geometrically, and we want to add them, we're basically going to make a parallelogram with the 2 vectors as sides. Then the actual addition is going to be the main diagonal of this parallelogram. So if this is u and this is v, this vector here is u plus v. So this is the parallelogram rule.